Let's begin with a question that's as unsettling as it is intriguing. Could we all be living in a simulation? Is this world, with all its complexity, nothing more than a sophisticated computer simulation made up of ones and zeros of code and data? Interestingly, this idea isn't as far-fetched as it may seem, and many scientists and philosophers have given it serious thought, even though concrete evidence remains lacking. But the concept of reality as something uncertain or illusory is hardly new. Eastern philosophy, for instance, has pondered these questions for centuries. Consider Zhuangzi's famous butterfly dream, the idea of not knowing whether you're a man dreaming of being a butterfly or a butterfly dreaming of being a man. It's a fascinating parallel to our modern curiosity about the possible relationship between reality and simulation. The scientific exploration of this idea was significantly advanced by Nick Bostrom, a Swedish philosopher, who published a paper in 2003 titled The Simulation Argument. In it, Bostrom proposed three possible scenarios. Firstly, humanity may simply become extinct before reaching a level of technological sophistication capable of creating simulations as advanced as reality itself. Secondly, perhaps humanity does reach that stage of advanced technology, yet future generations have no desire to create simulations of their past or alternate realities, for whatever reason. Or, thirdly, humanity eventually does develop the technological prowess to create highly sophisticated simulations, and in fact creates countless ones, resulting in the high likelihood that we are indeed living in one of them. The takeaway here is stark. If we aren't in a simulation, then the most probable reason is that humanity's trajectory toward technological advancement ends in extinction. But if we do manage to reach that level of technological achievement, it's human nature to believe that we would be inclined to create simulations. Imagine the allure of creating entirely new worlds where one could play out any role or scenario, becoming royalty, a famous inventor, or even the richest individual on the planet. The pull to escape reality's limitations and enter a simulated realm of near-limitless freedom would be, well, almost irresistible. Thus, we're left with two main possibilities. Either we are in base reality, in which case humanity may indeed face extinction before it achieves full technological potential, or we are already living within one of the many simulated worlds created by some advanced civilization that came before us. Now, this notion of a simulation universe continues to fuel debates in both scientific and philosophical circles. Some scientists have gone so far as to claim that the probability of us living in the real world is just 1 in a billion. This calculation is based on the assumption that if future civilizations have the capability and inclination, they would create a vast number of simulations. With so many simulated worlds, the odds that ours is the original one would be astonishingly low. Naturally, this line of thinking prompts a question. Is there any way to definitively determine if we are in a simulation? Several scientists have set out to investigate whether we could detect any flaws, any glitches in the matrix, as it were. If we were indeed in a digital construct, even one built by a highly advanced civilization, there might still be a few telltale bugs or limits in the system. These could manifest as odd occurrences in the natural world, perhaps a rock that appears identical to one we've seen before, but with a slightly altered color or repetitive phenomena that could be perceived as bugs. However, detecting such glitches in reality is no small feat. Take, for example, the Matrix film, where characters uncover inconsistencies that reveal their simulated world. While this makes for a thrilling narrative, observing such flaws in our reality is far more complex. Still, some researchers are examining the minutiae of our universe in pursuit of such clues. Silas Bean, a physicist at the University of Washington, has posited that even the most sophisticated computers might struggle to create a virtual world without limitations in resolution. If the universe is made up of discrete grid-like structures, what we might think of as pixels in a digital image, then the smooth world we perceive could, in reality, be built from tiny, indivisible units. Scientists are already conducting experiments to observe particles, such as photons or cosmic rays, as they move through space. They speculate that if these particles encounter certain pixel boundaries within the fabric of the universe, we might observe a slight shift or distortion, a signal, perhaps, that our reality is indeed a simulation. While no definitive evidence has emerged thus far, Discovering one of these bugs could be the most significant revelation in human history, potentially proving that we are indeed living in a simulated reality. If this theory holds water, some of us might simply be non-playable characters, NPCs, living our lives according to set programming, while others might be key players or main characters in the simulation. In this scenario, the autonomy we believe we have could, in fact, be an illusion. Our actions dictated by a predefined script written by an unseen programmer. Finally, let's discuss an experiment that's often brought up in simulation theory discussions: the famous double-slit experiment in quantum physics. Conducted in 1998 by researchers at the Weizmann Institute in Israel, this experiment examines the behavior of particles, such as photons and electrons, when observed. The findings are fascinating. When a particle is observed, it behaves like a particle, but when it's not observed, it exhibits wave-like properties. Remarkably, the more it's observed, the stronger the effect becomes. This phenomenon, known as the observer effect, suggests that reality itself may be altered by the act of observation. This brings to mind the idea that our simulated world could operate similarly to a video game, where a location only fully renders when the player turns to look at it. In other words, the world as we know it might only appear real when it is being observed, a theory that could imply our reality is programmed to behave as though it's real only in the presence of an observer. The observer effect observed in the double-slit experiment, that moment when merely observing changes the outcome, suggests that the world we inhabit might function much like a video game that renders reality only when observed. In video games, objects and environments that fall outside a player's field of vision often stop moving, or are represented in a simplified form to conserve memory. Then, when the player turns to look, the objects instantly return to full resolution. The double-slit experiment hints at a similar mechanism in our universe, where particles behave as waves when unobserved, yet shift to particle form the moment they are observed. In essence, particles seem to materialize only when they're being watched, an idea as intriguing as it is perplexing. This phenomenon has piqued the interest of many scientists. Theoretically, if no one observes these particles, they exist only as waves, probabilities, essentially. But when someone looks, they crystallize into particles. The implication here is remarkable. Perhaps the universe itself manifests reality fully only when it's being observed. If this theory holds, it suggests that we inhabit a sort of energy-saving mode when not observed, only materializing fully within the field of vision of a hypothetical player, thus conserving resources in the process. It points towards a meticulously efficient simulation. Several scientists believe that such features could be more than just speculative notions. They may well function as real physical laws, with our very laws of physics potentially being parts of this larger simulation. That is, what we understand as the laws governing our universe could be the result of mathematical formulas and algorithms operating within a digital construct. While providing definitive experimental proof of this remains a nearly insurmountable task, the hypothesis persists, fueled by countless observations where physical phenomena appear remarkably ordered, as if by design, and perfectly aligned with this simulated framework. Physicists such as Silas Bean have even explored the possibility that our universe might have a fundamental structure resembling a digital grid. In theory, if the universe's basic building blocks are constrained by such a grid, then space itself could be pixelated, much like the pixels on a screen. In a simulated universe, this grid would represent the system's resolution limit. When one tries to observe details finer than this resolution, one would encounter unavoidable limitations. Research is actively probing these potential boundaries. For instance, scientists are studying high-energy cosmic rays that travel vast distances across the cosmos to see if they exhibit any lattice-like patterns upon reaching Earth. If they do, it could provide the first indirect evidence of a simulated universe. Such experiments, if successful, would serve as monumental evidence that we are indeed residing in a highly ordered simulation, potentially coded down to the smallest particle. Thus, discussions of simulation theory have moved well beyond imaginative speculation and philosophical inquiry. They have entered the realm of rigorous scientific exploration and experimentation. If, one day, conclusive evidence of a simulation is found, it will fundamentally alter our perception of what we have long accepted as reality. The discovery would challenge our deepest held beliefs and compel us to reconsider the very fabric of existence. Let's imagine for a moment that this simulation hypothesis is like a giant MMORPG, a massive multiplayer online role-playing game. In this case, many of the physical constraints and phenomena we observe in our world could function much like game mechanics designed to maintain order within the game. In any large online game, a central server processes every player's actions and location. To avoid overload, the server limits the speed of information transmission, similar to the speed of light in our universe. Physics tells us that nothing in the universe can travel faster than light, the maximum speed for information transfer. This concept is much like a game server's restriction on data transfer, preventing it from sending information faster than it can handle. Thanks to this limit, the server can keep each player's actions synchronized with those of others, so interactions in the game world remain coherent and consistent. A game's graphics engine also has a resolution limit, which prevents it from being infinitely detailed. Objects and environments within the game are built out of pixels, and anything smaller than a pixel simply can't be displayed. Quantum mechanics has a similar principle. At extremely small scales, reality stops appearing as a smooth continuum and instead behaves as quantized pixels. For example, in quantum mechanics, physical properties like position and momentum can only be measured to a certain degree, beyond which they become indeterminate. It's as though our reality, just like the graphics in a game, cannot reach finer details than a set limit. The famous uncertainty principle in quantum mechanics mirrors this concept. If we precisely know an electron's position, its momentum becomes uncertain, and vice versa. This principle resembles the optimization technique in games, where the server loads only the details necessary at a given moment to save processing power. The simulation might operate in much the same way, loading only the information we're actively observing, making it appear as though certain details are missing or blurry when we attempt to observe them too closely. When the player base of a game grows large, a single server can't process all of the players simultaneously. To manage this, many games run multiple servers to distribute the load, with each server representing its own independent world. Players within each server share a consistent experience, but the servers operate independently. Similarly, the multiverse theory suggests that there may be multiple independent universes, each with its own set of physical laws and events, much like independent servers in a massive simulation. If our universe is part of a simulation, it may be just one of countless servers, or parallel universes, operating with different rules and conditions. Now, let's look at an intriguing idea proposed by Elon Musk. If our world is indeed a simulation, then the majority of people within it may well be NPCs, or non-playable characters. In games, many characters are NPCs who perform repetitive tasks according to specific programming, adding atmosphere and context to the game environment. For instance, we may see people strolling along the street or shopkeepers selling items, each one following a preset role. Musk suggests that if the simulation hypothesis holds, most people around us could also be living according to predetermined patterns and scenarios. If we accept this NPC analogy, the everyday patterns and social conventions we see could reflect a kind of pre-written programming. And if these NPCs can believe they are self-aware, then it raises the possibility that our own sense of self could also be programmed, a higher-tier NPC, so to speak. This could lead to the startling conclusion that our experience of free will might just be a trick of the simulation's algorithms, producing the illusion of autonomous choice. By exploring simulation theory through the lens of game mechanics, many of our world's physical limitations and patterns begin to make sense in a new way. The speed of light could be a transmission limit from the central server. The uncertainty principle in quantum mechanics could be our resolution cap, and the multiverse could represent multiple servers within a vast network. If this hypothesis is correct, we are indeed part of an enormous simulation, one where we and everything around us may be acting out roles in a sophisticated, universe-sized game. Let's think of this simulation hypothesis as a game. It becomes much easier to grasp. In a game, we have a consistent rule set that allows players to interact in predictable, systematic ways. This rule set is like the laws of physics in our world, governing every action and outcome within the game. For example, Rules about gravity, mass, and energy conservation allow characters to feel grounded in reality. Gravity ensures that when we jump, we land, and energy conservation ensures that explosions have precisely measured effects. The physical laws we experience could be similar constructs within a simulation designed to maintain consistency. These rules keep the game running smoothly, making the real world's laws of physics seem like the simulation's rulebook. So, when we make scientific discoveries, it's almost as if we're uncovering the game manual one page at a time. Now, each game character experiences the game's story differently, depending on their level of consciousness. Not all characters have the same awareness level. Some are simple NPCs, programmed only to wander or react to player actions, while central characters have more complex personalities and intricate story arcs. In a similar way, if our world is a grand simulation, each person's level of self-awareness and free will might be character settings. In games, main characters are guided by storyline missions and cues, but in our reality, these guiding scripts can feel like natural behaviors or social expectations. Elon Musk has suggested that many people around us might not be conscious players at all, but NPCs. He theorized that if we are in a simulation, then not everyone might have self-awareness or free will. Instead, some could be background characters, performing repetitive, predetermined actions to set the game's stage. When we observe how some individuals exhibit repetitive social patterns, this could, hypothetically, make them similar to background NPCs in a game. In a game, players have their own quests and objectives. Likewise, in life, each person has individual goals and paths, like a built-in mission system. Some people strive for success, others devote themselves to family, while others pursue philosophical understanding. These goals give life meaning, like missions provide purpose in a game. They could simply be designed to give us reasons to grow, experience challenges, and shape our character within the simulation. Much like quests in a game are structured to advance the storyline and character development, the challenges we encounter could be coded structures to help our simulation characters grow. If this hypothesis holds true, then our personal missions and ambitions might simply be part of the program to facilitate character growth and the accumulation of experiences. Online games regularly add new regions and storylines in expansion packs that extend the game world. Each new expansion brings fresh quests, items, and environments, enhancing players' experience. Multiverse theory, when thought of as expansion packs, implies that each universe could be a separate server or a new world with unique settings. The differing physical laws or evolutionary pathways in other universes might then reflect different server configurations in this vast network of reality. As players level up in a game, they become stronger and eventually reach the end game. Concepts like enlightenment in Buddhism or moksha in Hinduism parallel this process, where players see through the game's mechanics and transcend it. It's like completing the final mission and entering a new stage. In games, when players complete the main quest line, they are no longer bound by prior restrictions. They have a free mode, in which they're free from specific goals and constraints. Similarly, enlightenment in our reality could mean escaping from the simulation's constraints altogether. Simulation theory thus leads us to imagine that if we reach enlightenment, we might gain insight into the simulation's structure, freeing ourselves from its limitations. So, in summary, simulation theory, when viewed as a game analogy, helps explain the limitations we experience in reality, our challenges, our goals, and even our perception of free will. It's like understanding a game's mechanics. We start seeing how the rules shape our play, how we're supposed to navigate this complex reality game, and ultimately, what final level we're meant to reach. Simulation theory offers us a fresh way to think about reality and prompts us to wonder whether we're merely players, or something much more complex, in this grand cosmic game. The discussion of simulation theory isn't just fascinating. It has the potential to fundamentally alter our understanding of reality itself. If this theory proves true, then even the physical phenomena we experience and our sense of free will could simply be programmed rules or commands. If we take this idea further, we're faced with an even more profound question. Does this simulation have a creator or programmer who built and maintains it? If our world is truly a simulation, This naturally implies a designing intelligence behind it. And if this creator coded not only the laws of the universe, but also our individual lives and choices to some extent, then what we experience as true freedom may instead be a kind of designed freedom, limited within certain parameters. If we accept this hypothesis, our daily experiences, personal choices, and even ethical values could all be part of a preset scenario within the simulation's rules. This poses a philosophical challenge. Where does human free will fit? If what we perceive as making our own decisions is simply a programmed sensation, how would this change our understanding of life's meaning? These questions have sparked philosophical and religious debates for centuries. Religion often postulates a divine creator who governs the universe and humanity by some grand design. But simulation theory takes a modern scientific approach to this ancient question. If we're simply elements in a sophisticated experiment created by a higher intelligence, then perhaps we're highly advanced NPCs, non-player characters, in a vast simulation. But what if this simulation isn't the only one? Imagine there are layers of simulations within simulations, much like dreams within dreams. For instance, even within the simulation we inhabit, there might be other nested simulations. This concept, sometimes called meta-simulation, suggests that we could be part of a fractal-like structure of simulations within simulations, endlessly embedded. If our lives truly unfold according to a scripted scenario, what purpose might this serve? If our simulation exists purely for amusement or as an experiment, then the countless events, challenges, and even profound sufferings of our world might simply be features of the simulation. Scientists and philosophers are seriously exploring this possibility, seeking to understand the distinctions between real and virtual worlds. Simulation theory also redefines the meaning of human existence. If we are indeed living in a simulation, what then is truly meaningful in our lives? If pain, love, and achievement are merely experiences within a programmed reality, where should we seek significance? These questions are becoming more tangible as technology advances. With progress in virtual reality and AI, it's becoming less fantastical to imagine humanity creating a fully immersive simulation, indistinguishable from reality. If one day we're able to combine advanced AI with virtual environments to create worlds that feel as real as our own, then we would effectively become creators of simulations ourselves. Thus, simulation theory isn't merely a philosophical puzzle. It pushes us to question the reality we take for granted, and to consider our existence from a radically different perspective. Moreover, simulation theory raises questions about technological progress and ethics. If humanity someday creates perfect simulations, how will we define life within them? And if simulated beings gain self-awareness, would they be entitled to the same rights as humans? This line of questioning extends to modern AI research. With AI advancing, we may soon create systems that think and even mimic emotions. If AIs gain self-awareness and realize their programmed nature, how should we treat them? Would their experiences of pain or happiness be disregarded simply because they're programmed? These questions parallel today's discussions on AI ethics. If we develop AI that can learn and experience emotion, can we truly regard them as mere tools? If they exist within simulations, accumulating experience and self-awareness, they too might lay claim to certain rights, much like the way we're beginning to consider animal rights today. Simulation theory also challenges us to reconsider the meaning of our experiences, including suffering, joy, and accomplishment, if these are all artificially designed. Until now, we've believed that our experiences hold true significance. But if simulation theory is true, our lives might be nothing more than subjects of an experiment or observation, provoking deeper questions about the purpose of human existence. And if evidence were ever found that confirms simulation theory, how might it change our lives? People might begin to reject existing moral or ethical frameworks, deeming them irrelevant in a simulated world. This could lead to unexpected chaos, as people perceive laws and moral standards as arbitrary constructs rather than genuine guidelines for real existence. If simulation theory is proven true, it also brings into question the intentions of our creators. Did they design this world with a purpose? Or is humanity a mere experiment waiting for its conclusion? Some may find this notion unsettling, while others might see it as a possibility for eternal life if existence in a simulation means we're part of a self-repeating structure. Ultimately, simulation theory asks us to rethink our understanding of life and existence. No longer can we assume the line between real and virtual is absolute. We may need to view reality through a new lens entirely. While these ideas remain speculative, advancing science and philosophy mean these questions are becoming more relevant than ever. One question simulation theory raises is whether we could gain control over this simulation. If we're within a simulation, could we hack or modify it? Could we escape its limits and perhaps even encounter our creators? This idea becomes more conceivable as virtual reality progresses. Already, we see AI learning to exploit patterns in simulations, using tactics like bug abuse or hacks in games. If we too could identify such patterns in our world, we might imagine ourselves finding glitches or inconsistencies that lead us toward a greater reality beyond. Some have compared this to concepts of awakening in Buddhism and Hinduism, seeking enlightenment as a process of realizing the true nature of reality. This pursuit of transcendence, of seeing beyond the surface, could indeed parallel ancient teachings about liberation, suggesting that the ultimate human goal might be to transcend the simulation itself. However, it's difficult to imagine how we could actually achieve this in practical terms. If we are truly within a simulation, it's likely that the creator of this system has limited our access to its underlying structure, preventing us from modifying or bypassing its constraints. In other words, the creator may have designed the simulation to be unbreakable from the inside. Nevertheless, some scientists and philosophers speculate that subtle anomalies within our physical laws might serve as clues. Much like discovering an error in a code or a glitch in a game, there may be irregularities in our reality that hint at a simulation. Quantum phenomena, such as the double-slit experiment's observer effect, where physical outcomes seem to change when observed, might be one of these clues. Armed with these hints, scientists are re-examining our physical laws, searching for unusual patterns that wouldn't exist in a non-simulated world. If one day we find undeniable evidence that we're in a simulation, it would represent the greatest philosophical and scientific revolution in human history. Simulation theory ultimately broadens our perspective and questions the very foundation of what we call reality. If it were proven true, we'd need to reevaluate all human achievements in science and philosophy. Ethical issues, for example, would be reconsidered through the lens of simulated existence. We would question whether simulated beings deserve rights, and whether simulated pain or pleasure holds real meaning. And this shift in thinking could change our approach to the virtual worlds and AI we're creating. If humanity someday builds fully immersive simulations and experiences new identities within them, then simulation theory might indeed become our new reality. In the end, simulation theory is far more than a philosophical curiosity. It prompts us to question the world we've always accepted as real, challenges us to rethink human existence, free will, and the very concepts of reality and illusion.
Subscribe it.